Okay, good evening everyone. I welcome you all for this machine learning session 2. So in the previous session we have been looking at some of the introduction about machine learning concepts, and we saw different types of machine learning like supervised learning, unsupervised learning and reinforcement learning, and also we discussed about the steps in machine learning process, and we was discussing about one algorithm that is called linear regression, okay, which is used to estimate the salary of an employee based upon the number of years of experience. Okay, so in this session we are going to look at some more algorithms. The first algorithm we are going to look is support vector machine. Okay, so in the previous session we were discussing about linear regression algorithm, that is actually a regression algorithm. Okay, so as I discussed already, there are basically only two kinds of problems in machine learning. One is classification, the another one is a regression problem. Regression is nothing but prediction. Okay, so yesterday we saw about regression problem. Today we will be looking at one classification problem. Okay, so if you look at this small example here, there is some different types of images given, cat and dog. Okay, so the model is going to identify whether it is a cat or dog. Okay, it's a classification problem. It is going to classify whether the given image belongs to cat category or dog category. Okay, so that is what called classification problems. Okay. Okay, so that's a small example for SVM algorithm. So in this problem, what we are going to do is, this is the data set given to you. So this data set has user ID, gender, age, and then estimated salary. Then there is a column called purchased. Okay, so purchased is the output actually. Okay, so based on these factors like ID, gender, age, salary, we are going to predict that whether the person is going to purchase the car or not, or purchase the bike or not. Okay, so that is what the output actually. 0 means the person is not going to buy the bike. Okay, and 1 means the person is going to purchase the bike. Okay, so that is what your output, that's what we are going to predict. Okay, this column, this is the output column, and we are going to take these are the inputs. Okay, the other 4 columns. Okay, so in these 4 columns you will have to identify which are the columns relevant to the output. That is, the output depends on which columns. Okay, the person is going to buy the bike or not, the decision depends on maybe the age and salary, but definitely it is not depends on user ID. Okay, sometimes the gender also influence the decision. Okay, so here we are going to take only the age and salary variable, so the decision of the person is going to depend on only age and salary. Okay, so this is the explanation about the data set. Now with this introduction we'll go into the algorithm. Okay, so SVM algorithm. So first let us import the necessary packages, numpy, matplotlib, pandas. Okay, and then I am going to read the data set, and this is the data set name, SUV data. First of all, let me load the file. Let me upload the file. Okay, now the data set is loaded, svdata.csv. Now this data set is read now. Okay, pd.read csv, svdata.csv. and then you print the data set. So when you print the data set, you will get the output like you can see so let me show you the first output. First of all, let me comment this, or otherwise I put it in another one. It's a big output, so we are not able to track. So let me take it out this. Okay, so this is the data which is available in the Excel file. Okay, user ID, gender, age, salary, and purchase. Okay, so now we have just read the data set. Now I am going to insert one more row. Here I am going to extract the dependent and independent variable. Okay, so as we discussed in the previous session, the dependent variable is the last column. Okay, decision column, that is purchased or not. Okay, 0 or 1, that is the output which is depends on age and salary. Okay, so the age and salary is this is column number 0, 1, and this is column number 2 and 3, and this is column number 4. Okay, so just remember this. Now we will split it here. Okay, so here what I am doing here, in the X I am going to extract the independent variable. Independent variable we are going to consider only age and salary. Okay, so age and salary is available in the column number 2 and 3. Okay, so colon, there is no number before and after the colon, so that it will extract all the rows. Okay, and column numbers 2 comma 3, so it will extract both the columns, full complete column. Okay, that is the independent variable. Dependent variable is available in y equal to dataset dot index location colon comma 4, fourth column, that is the last column. Okay, where I am having the output, that is a purchase 0 or 1. Okay, so this is how we are splitting x and y. So this step also we have seen yesterday. So after splitting, you can see your data set. I am having age and salary in x. Okay, and you can see here I am having zeros and ones, that is the last column in the y variable. Okay, now after doing this, we are going to split x and y into training and testing set. Okay, you can use this function sklearn.model selection, import this function train test split, and use the function here and split x comma y. The test data size is 0.25. It means that 25% of the data is used for testing, the remaining 75 is used for training. Okay, the random state equal to 0 means first 75% is used for training and next 25% is used for testing. Okay, now once it is splitted and it is stored in these variables x train, x test, y train, y test. Okay, because x is splitted into training and testing, and y is also splitted into training and testing. Okay, now after splitting this, now we are going to do a scaling. Okay, scaling is something like normalizing the data. Okay, so when you look at for example the salary column, okay, the range of data is more. For example, it may be from 10,000 to 1 lakh or 2 lakh, something like that. Okay, so I want to reduce the range of the data, so I am going for feature scaling of the data, or you can call it as normalization. So for that I am going to use this package sklearn.preprocessing, import standard scaler. So create an object for this, then use this function stx fit transform. Okay, and then supply the training data and testing data of x. Okay, and then you can see your data after transforming your data will be mostly in the range of -2 to 2, okay, or maybe -3 to 3, not more than that. You can see here 2.06 is the maximum value. I think this 2.16, okay. So almost it is between -3 to 3, not more than that, okay. Even if you have the data in terms of lakhs, it will be converted into a small range. This is for especially to make the processing easier, okay, in the machine learning model, okay. Now you have converted the data. Now what you are going to do, you are going to use the support vector machine algorithm, okay. So for that, from sklearn.svm, import this support vector classifier, okay. So use this support vector classifier and train the model, okay. So create an object for that classifier equal to svc. We are going to use the linear kernel and random state equal to 0. Then you do the training. Classifier dot fit means we are going to train, okay. Do the training with x train and y train. Okay. So once the training is done, the model is created now, okay. So after the creation of the model, you will get a box like this. So it shows that the model is created, okay. Now after this you can start doing the prediction, okay. So before start doing the prediction, you need to test the model, okay. So for that, y predict equal to classifier. This is the model that you have built now, classifier, okay. Classifier dot predict of x test, okay. So supply the testing data, then you can start getting the output for the testing data. You can see here, this is the testing data, okay, and the output is, see here, this is the output, okay. 0 1 0 1 means 0 means you will not purchase the bike, 1 means you will purchase the car or bike, whatever it is, okay. So that is about the SVM algorithm. So after doing the testing, you can start doing the predictions, okay. So you can give some new data and you can do the prediction. Y prediction equal to classifier dot predict. Here you should not give the age and salary directly. You should convert into, use some scaling, and you should convert that into a small range of data, and you can run this. You will have to run all the cells, okay. Let me run all the cells. Now you are getting some data, that is 1. For example, if I am giving something in negative, let's see what happens, okay. So now you are getting 0, okay. So depends upon the age and salary, so this decision will change, 0 or 1. 0 means you will not purchase the bike, 1 means you will purchase the bike, okay. So this is what the SVM algorithm is. So here, one second, okay. So here whatever I have given you is only the core part of the coding. There is a coding for only the SVM, support vector machine algorithm alone, okay. So other process and all same, like it applies for all the algorithms, okay. The other process is, first read the CSV file, import the package, read the CSV file, split it into dependent and independent variable, then split into training and testing data, and if you want to do the scaling you can do it, otherwise you can leave it, okay. This is I just want to show you how to do the scaling, so that's why I have included this. And after this, do the training, import the model and do the training, okay. Then after this, you test with the testing data, and then you start doing the predictions with your own data, okay. So this is the general steps followed in all the machine learning algorithms, okay. Now I'll show you, there is one more algorithm called KNN algorithm, okay. This is called k nearest neighbor algorithm. This is also one of the classifier algorithm. Okay. It works basically depends upon the similarity between the new data point and there may be more than one category, maybe class 1, class 2 or category A and B, okay, something like this. The distance between this new data point, okay, and the category, if this data point is nearer to this category, then we can classify this belongs to this class, or if this data point is nearer to this category, then you can decide that this belongs to this class. Okay, so that is the way we are deciding which category it belongs to. Okay, now let's go into the coding now. Here you can see here the other process and all same. First import the package, then read the CSV file, then split it into dependent and independent. The all codings are same. Split it into testing and training. The only portion where is the changes I will show you. The scaling is also same coding, no changes. You can see here. Previously we have used SVM. Okay, that's why I am keeping the coding also same. Only this portion I am going to change. Okay, now I am going to use KNN algorithm. Okay, so here just import the model, necessary model, sklearn.neighbors, import k neighbors classifier. This is the algorithm you need to import, and you create a object for this classifier equal to k neighbors classifier. You need to mention the number of neighbors that is going to be considered. Mostly it will be taken as 5. Okay, 5 neighbors will be considered, and metric we are going to use the default metrics, min, cost, key metrics, and p equal to 2. Then classifier dot fit means you have to train the model using this training data. Okay, so only this 3 lines will change. The other things are as usual similar to the previous algorithm, common for all the algorithms. The other steps are okay. Now after doing this you can test with testing data, and after testing you can go for prediction. Okay, just give some data, then you start predicting it, then it will give you the result. The same problem, whether the person is going to buy the car or not, okay, or bike or not, whatever it is. Okay, same data set we have used. Only thing we have changed is the same problem, same data set. Only thing we have done is we have changed the algorithm alone. Okay, the algorithm alone. So like this you will have lot of algorithms. We will have list of machine learning algorithms. If you see, to show you, like here only some of the list is shown. Basically you will have supervised algorithms. I will go 1 second, let me show you that list. So you can go to any website which may list out. In Google, it will give you some list, nice list I have seen somewhere. So you can see here under supervised learning, you will have linear regression, logistic regression, decision trees, then support vector machine, KNN algorithm, naive bias, random forest, gradient boosting, neural network. Okay, so all these algorithms will come under supervised learning. Okay, so it includes both classification and regression algorithms. Okay, in unsupervised algorithm, clustering algorithm. Under clustering, you will have many algorithms like k-means clustering, fuzzy c-means clustering, then dimensionality reduction algorithms, association rule. Okay, so like this you'll have some algorithms. Okay, so you can with the basics whatever we have learned till now, with these three algorithms you can explore the other algorithms also. Okay, the same kind of work you will have to do, but you will have to import the necessary model from the uh, package, sklearn package. Okay, so that is the thing only you will have to do. Okay, now let's look at one more problem that is called handwritten character recognition. Actually, this problem comes under deep learning. Okay, so deep learning is like when your data is unstructured, or when your data is very huge. Okay, we will go for a deep learning technique. Okay, this one I am taking it as a extra class. I am taking it as a bonus. Okay, just to give you an exposure about what is deep learning, how the deep learning project looks like. Okay. Okay, so let's start. Let's understand the problem first. What is handwritten character recognition? Okay, you might have seen handwritten digits, something like this. Okay, so we'll be writing digits from 0 to 9 in different ways. Okay, I may write one this way, and you may write one this way. Okay, everyone is writing the digits in different ways. Okay, and there is an algorithm which will recognize the digits, which will scan and recognize the digits in whatever way you write. Okay, so that is the problem here. So to recognize this, you will have to train the model. Okay, the machine will not immediately recognize when you give the input. Okay, so your input is these digits. Okay, these digits are recorded as image. Okay, image in the sense it's a 28 cross 28 image. Okay, 28 cross 28 is image is nothing but a set of pixels. Okay, 28 rows and 28 columns, pixels will be there. Okay, so each box is a pixel. Okay, so this box is there, no, this box size is 28 cross 28. Okay, so if you want to show one pixel as block, you'll have to make this as 0. Okay, and if you want to show this pixel as white, then you have to make it as 1. Okay, so if I want to show this pixel as black, then you make it as 0. So that is how you have to record the images inside your memory. Okay, in the computer. Okay, now so for this you need a lot of images to train the model. Then only when you write the digits in any manner, it will start recognizing the digits. Okay, it will not recognize if you train the model with only 10 images or 20 images. Okay, so I am having a data set. So this is my data set. If you look at the data set, you can see here it's a 28 cross 28 matrix data. Okay, 28 cross 28 means around 784 pixels will be there. Okay, you can see pixel 0, 1, 2, 3. It may go up to pixel 783. Okay, pixel 783 is here. Okay, let me zoom this. Okay, pixel 783, so it means 784 pixels are there. Okay, then so 0 means black. If you give some other number, it is white. Okay, so the first one is, the first column is the output. Output is what we are going to classify based upon the pixel images, pixel intensity values. We are going to decide that whether the given image is a what is that given images is 0, 1, 2, 3 or 9. Okay, so we are going to classify the given image belongs to which class, 0 class, 1 class or 9 class. Okay, so with this data we are going to train the model. Okay, this shows the first, for example, the first row shows it's a number 1. For this number 1, these are all the pixel intensities it is recorded. Okay, and this is again 0, 1, and this is for number 4. These are all the pixel intensities recorded. Okay, so like this I have around 42,000 data here. Okay, nearly 42,000 data is there. 42,000 data for 9 digits. Okay, it means around 4,200 data for 1 digits we are having it. Okay, now we are going to feed this data and we are going to train the model. Now let's see how to do it. Okay, so import these packages numpy, pandas, matplotlib and sklearn. This is for train test splitting. Then you need TensorFlow and Keras. Okay, so these are all the packages which is used to implement a deep learning model. The deep learning model name is called as sequential model. Okay, so we are going to import sequential, then dense, flatten, then to categorical. These are all the functions we are going to import. Okay, now let's read the data set first. Training data equal to pd.read.csv. Here I have loaded the data set which is available in the Google Drive itself. Here I am not going to load it now. My file mnist train is there. No, just now I have shown. This is the mnist train. Okay, this is the Excel file I have loaded in the Google Drive. So this one I am going to read it now and I am going to store it in the variable called training data. Okay, then from the training data you just print the shape of the training data. The shape of the training data is 42,000 comma 785. 42,000 is the rows and 785 is the columns. 784 pixel values and the first column is the output column. Okay, 1, 2, 3 or 9, 0 to 9. Okay, then I am going to split it into x and y. Okay, so as I already told you, x is the independent variable and y is the dependent variable. Okay, so always y is the output. Okay, so y is the output is the first column, that is the 0th column. Okay, so I am extracting 0th column here and x is having the column numbers from 1 to till the end. So that's why here 1 colon, there is no ending given here. Okay, so column number 1 to 783. Okay, pixel 783 is there. No, till that all the pixel values will come into this x. Okay, now we have splitted in x and y as dependent and independent variables. Okay, now I am printing the shape of the x. The shape of the x is 42,784. Okay, the whole data set shape is 42,785. Okay, one first column is output, so we have eliminated that, so that is in y. The other columns are in x, so that is 784. Okay, now Now in this portion, we are going to convert all the data to numeric, and then wherever the values are missing, I am going to fill with zeros. Okay, so that's why we are using a fill and a. Then I am going to normalize the data in case if it is more than 255. Okay, just divide by 255, you will get the values, the normalized values, that is the scaling data, scaled data. Okay, now again you reshape the data. After reshaping, you will get as a one dimensional array. So shape of x after reshaping, you will get it like this: 42,000 28 into 28 into 1. Okay, you will get it like a matrix. Okay. Then I am going to use this two categorical function, and then I am going to convert this classes. Okay, the y data is available in the first column, that is 0th column, that I am going to convert it into number of classes. Okay, number of classes equal to 10. 10 means 0 to 9. Okay, now after converting into categorical data, you need to split x and y into testing and training data. Okay, so use this train test split x comma y. Test size is 0.2, that is 20% for testing and 80% for training. Okay, then random state equal to 42. 42 means it may take randomly the training data and as well as testing data. Okay, then so x train shape equal to 33,600. It means that 80% of 42,000 is 33,600. So that's why we are having in the training data the 80% of the data x train. Okay, then after splitting the training and testing set, you need to create a deep learning model. Okay, so model equal to sequential model. This is the basic model in deep learning. Okay, sequential model. Here in the deep learning model, you will have number of layers. Okay, for example, if you look at any deep learning architecture, okay, your architecture looks like this, where you will have a number of layers. Okay, so this is the input layer and this is the output layer. In between you may have any number of layers. Okay, so these layers are called hidden layers. Okay, so in the input layers I am going to supply all the pixel values, that is around 784 pixel values is there, no? So that 784 lines is the input for you, input for this deep learning model. Okay, and the output is the 10 classes from 0 to 9, 0 1 2 3 up to 9. There will be 10 outputs at the end. Okay, so in between there may be a number of hidden layers like this. Okay, hidden layer 1, hidden layer 2, something like this. So all the inputs will be passed to these hidden layers. Okay, so that is what we are trying to do here. Okay, the first one is the input layer, 28 cross 28 into 1. Okay, 28 cross 28, you will get 784 pixels. Okay, one dimensional matrix. Then the next one is the hidden layer. The next one is also the hidden layer. Okay, so hidden layer is where we are going to use 128 filters and 64 filters. Okay, so the output of this layer, the second layer, will be 128 and the output of this layer will be 64. Okay, 64 outputs will be there, and this is the final layer where you are getting the output. Okay, dense layer. All these things you will have to mention as a dense layer. Okay, then the output of this will be 10. Okay, 10 means that is 0 to 9. Okay, now you have created the model. Now you need to compile the model. Okay, model dot compile optimizer equal to Adam. Okay, we are going to use the Adam optimizer, and loss, what is the metric you are going to use, and for accuracy, what is the metric you are going to use. These are all the things you will have to specify. Okay, for to estimate the loss, I am going to use categorical cross entropy. Okay, this is one of the metric, and I am going to use accuracy to evaluate your model. Okay, so these are all very basic default things, so you just leave it as it is. Okay, you just understand what it is, and after compiling the model, you just print the summary of the model. Okay, now after creating this, you will get a output like this. So it means that, so this is the input layer. I am having 784, and after the first hidden layer I am getting 128, and second hidden layer you are getting 64. At the output layer I am getting 10. Okay, now once the model is ready, now I am going to compile the model. Okay, here history equal to model dot fit x train y train comma epoch. Epoch is equal to 10. It means that how many times you are going to train the model. It doesn't mean that if you train one time the model will be ready. Okay, so you'll have to train multiple times so that till you reach the accuracy, expected accuracy. Okay, so then batch size is there are 42,000 data I told you. You cannot give all 42,000 data at a time. Okay, so that is the purpose of the batch size. How many data you are going to give it to the model at a time to train the model. Okay, so that size is actually 32. Okay, we are going to supply only 32 rows, and we are going to do the training at a time. Okay, then validation data equal to xval and yval. Okay, so that is available here when you are splitting it. Okay, you can see here. Okay, so when you split it into training and testing, that is stored there. So that is supplied here for validation. Okay, now when I run everything, now the model start training. There is an error here. Choose file not found error. Let me check. Okay, now the data is loaded. Take some time for mounting the Google Drive. Okay. Now you can see how the training happens here. See here, epoch 1, 2, 3, 4, 5, 6, 7, 8, then 9, then 10th time. So 10 times the model is trained. Why? What is the reason? Just to improve the accuracy of the model. You can see here, first time, that is epoch 1, what is the accuracy you are getting? You are getting only 84%. The loss is 0.5. Okay. Next time you can see 96, Here loss also decreased. Accuracy is increasing, loss is decreasing. Okay, so you can just monitor this. The accuracy is keep on increasing, but you can see at this point 99.51, so that is the percentage, and after this the 99.3 has come. Okay, that is the accuracy starts decreasing. Actually, after 99.5 it has to increase 99.7 or 99.8. Okay, but it start decreasing. Okay, so this is called overfitting or overtraining the model. Okay, so you should not do like this. You should train the model only whatever required number of times. Okay, that you cannot identify, you will have to identify using trial and error method only, like this. So here what you can do, you can stop with this ninth iteration, that is when the ninth approach is completed you can stop it. Okay, you no need to go for 10th iteration. Okay, so we have trained 10 times, so we are getting this is the accuracy we are getting. And similarly you can check validation accuracy also. Validation accuracy and validation loss, this is with respect to validation data, that is testing data. Compared to this accuracy, this validation accuracy will be lesser only. Okay, this is we are testing with the testing data, and similarly loss also will be more than this. Okay, so now we have trained the model now. Okay, now for the output whatever we got now, we are plotting the graph now. Okay, so the graph is plotted for training accuracy and validation accuracy. You can see, so the orange graph will show you the validation accuracy, and blue color shows the training accuracy. Okay, now next our job is we'll have to test the model, how it works. Okay, you can see here I am loading the testing data now, pd.read.csv. So this is the file where I am having the testing data. So let me show you the testing file also. You can see here, this is my testing file. Here I don't have the output, you can see only the pixel values I am having, 00 till 784 pixels you may be having. Okay, pixel numbers are not given, so 784 pixel values are given. So that is my testing data, maybe around 10 data will be there. Okay, now you as usual you normalize the data but divide by 255 and do the reshaping, and then you do the prediction here, prediction model.predict x test. So supply the testing data here, and when you are doing the prediction you are getting the outputs like this, as you can see here. So this is my 7, this is the input I have given, this image is the input, so predicted is 7. Okay, and you can see the next one, this is the input image 3 and predicted 3. So everything almost it will predict correctly. The next 3 is this, the next 0, the next one 5. Okay, so we have given almost 5 images, so it has predicted all 5 images correctly. Okay, because the accuracy we got is around 99.5%, so almost it works for all the images. Okay, so this is what actually called as one problem which we have discussed under deep learning. Okay, so like this you can explore more problems on deep learning. It may be like heart disease prediction using some CT scan images, or brain tumor prediction using some MRI images. Okay, so the same operation you'll have to do. You'll have to first take the images, supply to the deep learning model and train the model. Next time when you give the new image, MRI image or CT scan image, the model will automatically predict whether the image is having a brain tumor or not, something like that. Okay, so that is the kind of problems we'll be solving with deep learning models. Okay, mostly the deep learning models for is used for images, audio and video kind of data. Okay, so that's all about this machine learning and deep learning algorithms. Okay, so I will end up this session with this algorithms. Okay.